Hi, this is Alex Young. I'm a heliophysicist at NASA's Goddard Space Flight Center. And many of you may have seen the video recently that showed the sun for the past 3 years observed by the Solar Dynamics Observatory. I also saw this recently, thought it was a really cool video, and I want to share with you some of the interesting features I noticed in the video. If you see that big black disk that moves over the sun, that's the moon, what we call a lunar transit. That's when the moon is moving between the sun and the SDO spacecraft. It almost looks like a perfect circle, but if you look really close on the edge, you see these little tiny humps. Those are the mountains on the moon. Just an amazing thing you can see with these incredibly high-resolution cameras. We're looking at the 171 angstrom wavelength. This is extreme ultraviolet. It's showing us the solar atmosphere at about 1,000,000 degrees Fahrenheit. And if you look at this image, you can see all of these bright patches. These are active regions associated with sunspots. And then you even see loops. These are huge structures, many times the size of Earth, that are magnetic fields holding in this hot solar plasma. One of the things that's amazing about this is there's so much stuff going on in this image as we're looking over time. There's a really big flash on one side of the sun. That's a solar flare. And in this case, it's the largest solar flare that happened during this particular solar activity cycle. One of the coolest things that we can see from this video is the simple fact that the sun rotates around its axis. The center near the equator takes about 25 days for it to rotate all the way around and come back to the same place. Now, I'm pointing this out because the sun has a special feature, something called differential rotation. A point on the equator actually moves faster than a point closer to the North or South Pole. One thing that happens is sometimes the images move, the sun moves around or even rolls, but that's actually the spacecraft moving, not the sun. SDO has to occasionally roll the entire spacecraft in order to calibrate the cameras and instrumentation on board. If you notice, those bright patches, those active regions, start off towards the poles of the sun, and as we move in time, they start to slowly creep towards the equator. This is part of what we call the solar activity cycle or solar cycle, as we move from very low activity with very few sunspots to high activity with a lot of sunspots. This is something that happens again and again, and it's happened for millions of years. And now we can see the sun in multiple wavelengths of light simultaneously. We see the visible sun, where you can see the dark sunspots. And then if you look at the 171 extreme ultraviolet, you see the corresponding bright areas and the magnetic loops coming from them. If we go to the 193, you see even more structure, and you see these dark patches. And this is where magnetic fields are open out into space, letting out something called the solar wind in these very fast streams of particles. And then the last one, the red one, is 304 angstrom, and this is showing us what we call the chromosphere. And these red areas are often visible when you see the sun from total solar eclipse. Did you see that little tiny black dot that's close to the North Pole in the sun? That's Venus. Every 100 years or so, it moves in front of the sun, giving us this rare and amazing astronomical event.